everybody. Welcome to another Weather Wednesday. My name is Elias, and I'm using Science on a Sphere today to show you something that has nothing to do with weather. Today we are going to be talking about volcanoes and earthquakes. These are not weather events, but they do impact us here on the Earth. So we're going to take a look at some interesting data sets pointing out just the different earthquakes and volcanoes around. This first one that I want you to take a close look at shows all of the earthquakes and volcanic eruptions around the world over the last 40 years. This is data from 1960 to 2010. And you can see that there are a lot of eruptions and particularly a lot of earthquakes. All those white dots are earthquakes. The larger the dot, the stronger the earthquake. The red triangles are the volcanoes. The larger the shape of the volcano, the stronger the eruption. As it's going around, it's pointing out some key or significant volcanic eruptions that happened between that 1960 to 2010 time frame. And you see that it kind of almost follows certain patterns here. And what I want you to think about is why. Why do these earthquakes seem to happen in certain areas? And why do these volcanoes happen in certain areas? There is quite a pattern to this. And look at how active certain areas are. We're going to take a look at that. We're going to take a look at this with our next data set, which is, I want to see what it's like under the water. So if we had the Earth here, and if we could take away all the water, if we could pull the plug and suck it out, drain all the water, this is what we would end up with. And you can see here in the ocean, right in the middle there, you have a big crack, a big scar, if you will. This is called the Mid-Atlantic Ridge, right here. And then you also saw a lot of activity around the outside edge of the Pacific Ocean here. A lot of scientists refer to this as the Ring of Fire because you will find so many volcanoes occurring along this outer edge of the Pacific Ocean. Now what I want to do is, I'm going to bring up another data set here that I want to show you. And this, so what is happening is that our Earth is covered in rocky plates. These plates are floating on top of liquid magma or liquid rock. And as these plates are moving around, they're bumping into each other. They're sliding around, bumping into each other, and there's certain ways that they could bump into each other. First, you can have two plates come together. This is called converging plates. Now, the areas where these plates are bumping into each other, where there's a big crack, that's called a boundary, or sometimes people refer to it as a fault. So there are a bunch of boundaries within our Earth's crust, and where these plates are coming together, that's called a convergent boundary. On this picture, you can see that the green lines, right here, particularly on the coast of South America there, the green lines are converging plates here. Over on the west part of the Pacific right there, you also see a lot of green lines. So that is a converging boundary. When two plates are separating, that's called a divergent boundary. And so we see that very much in the ocean, the bottom of the ocean, right? In the Indian Ocean there, as well as that Mid-Atlantic Ridge, which I was pointing out. Lastly, we have two plates that might move side to side. If the plates move side to side in this data set, they're purple lines. This is called a transform. Trans means across. So sideways moving transform boundaries. Now, many of you might be asking, when you're thinking about these earthquakes and these plate movements, you immediately think of California. What's going on with California? Well, here is a picture. Let me move back into my data set here. Here is a picture of that fault in California, right here. In California, the fault is a transform fault. This is an aerial picture of one of those, what's called the San Andreas fault in California. And that is a transform fault, so it's going side to side. Now, in my mind, I always ask, what's the strongest or most destructive fault? And the answer is convergent. When two plates collide, somebody's got to win. And usually the thinner plate goes underneath the thicker plate. Well, when the thinner plate goes underneath, sometimes that plate will pop up. And when it pops up, that causes a pretty big earthquake. And if there's water above it and that plate shifts up, you're going to get a tsunami. What's a tsunami? A tsunami is a large mass of water, a huge wave, and subsequent waves that travel across the ocean. So a tsunami, even though it has lots of water involved, is not a weather event. It's caused by the motion of the plates under the ocean floor there. So we have seen different plate motions, different plate boundaries, and recently we have been seeing some volcanic eruptions. Here's some pictures of some volcanic eruptions. Actually, let me go to the pictures here. So this is a picture of the volcano in the Philippines, Volcano Taal, that erupted just a couple weeks ago, significantly. Here's a closer image of that volcanic eruption there. So it's still very dangerous right now. Volcanic eruptions can occur whenever we in places that we don't know, at times that we don't know about. There is a little bit of a warning that scientists can see for those volcanic eruptions. One thing they're looking for is earthquakes, earth tremors, and even in the last 24 hours, there have been over 450 volcanic tremors or small earthquakes centered right around that Volcano Taal. So scientists are still warning the people in the Philippines that this volcano could erupt at any time. Now, the challenging thing is that people that live there or people that live near that volcano, it's not really erupting right now. There's not a lot of ash coming out of it right now. So they ask themselves, well, is it safe to go back? And my home is there. Can I go get my stuff? Well, this volcano could erupt at any time. So there's a struggle with people, residents that live there. A struggle, should I go back there or not? Is it safe or not? So scientists are warning people to stay away from Volcano Taal. And then even back in December of 2019, December of last year, there was a volcanic eruption in New Zealand, on an island of New Zealand, that made the news as well. That one was kind of unexpected as well. It's not erupting still, but a small volcanic eruption happened there. Now, a couple questions that have come up on the internet here. A question from Michelle. One question is, can you see these data sets on the internet or anything? And yeah, if you go to NOAA, N-O-A-A, SOS, Science on a Sphere, sos.noaa.gov, so sos.noaa.gov, you can look at many of these data sets on there. Some of the ones, like these pictures right here, I've created, and so they are here at the Space Foundation Discovery Center. But there's several data sets that you can look at for earthquakes and volcanoes. Another question that came up, why do subsequent earthquakes happen minutes after a large earthquake? And how does that earthquake affect the opposite side of the same area? That's a good question, and to answer this, we're going to look at earthquakes in real time. These are all of the earthquakes that have happened recently around the world. Starting with, looks like December 23rd, so over the last 30 days, all the way up to today's date. So this is looking at earthquakes over the last 30 days, so I'm going to push play here so that you can kind of look around. And you can see that the larger the circle, the stronger that earthquake is. The color of the circle will tell you how deep it is. The reds and oranges are shallow earthquakes. The blues and purples are deeper earthquakes, which you won't feel quite so much. And here's a trivia question for you. What state experiences the most earthquakes? Answer is not California. The answer is Alaska. And that has a big reason why it's on the ring of fire there, is because these islands right along that plate boundary there is very active, moving a lot. And there are a lot of volcanoes that are erupting there off the coast of Alaska as well. So, looking around the ring of fire, there's lots of earthquakes that are constantly going on. And if there is a big earthquake that would happen on one side of the world, sometimes we would see a big earthquake happen on the opposite side of those plates. So the Earth is constantly seeking that equilibrium, that balance point. And if there's a big earthquake or a big adjustment on one side of a plate, possibly there might be a balancing earthquake on the opposite side. But there's no correlation to that yet. Nor is there any prediction of when an earthquake might occur. So, we have one more question. The question is, what about the dormant volcanoes on Mars? Well, now you're taking it to space. So that is some great questions. Are there volcanoes on other planets? And the answer is yes. On Mars, there are many extinct volcanoes on Mars, but there are currently active volcanoes going on two places that we know of. One is the planet of Venus. Venus is very volcanically active, and the other is the moon, Io, that is orbiting Jupiter, and that moon, Io, is also volcanically active as well. So yeah, there are volcanoes going on throughout our solar system, and what we are learning about our volcanoes, we can apply to our knowledge and understanding of volcanoes in other places in our solar system as well. So what else do you guys want to know about? Feel free to send us some comments and suggestions on topics. We encourage you guys to reach out to us with your questions. And if you send us a question, we would be happy to send back a response with email too. So feel free to contact us here at the Space Foundation Discovery Center. I'm going to leave you guys with one more data set here. And that is just a little perspective here. This is kind of an interesting data set that NOAA created. And it's going to start up here. But this is talking about the magnitude comparison of earthquakes, the amount of energy released. This circle right here is a 5.8 earthquake. This circle right here is an earthquake that hit Northridge, California back in 1994 as a 6.7. This is the amount of energy released by these earthquakes. This one right here is the Haitian earthquake back in 2010. big earthquake that hit Haiti. And then as we get more and more and more, this one right here is the San Francisco earthquake of 1906. The two pink ones are Mexico and Samoa. And I'm going to slow this down just a little bit here. This is, at this peak level right here, this is a Bolivian earthquake. And then we got another big one coming in here. Again, this is showing, comparing the amount of energy released in earthquakes. And you see there is an exponential factor. It's called logarithmic scale of the strength of earthquakes. This one, this red one coming up right now, is an 8.8 in Chile back in 2010. Then we have the one that hit in Japan in 2011. And this one right here is an Alaskan earthquake, 9.2 back in 1964. And then as we continue on, the largest one here is a earthquake in 1960 at a 9.5 back in Chile. And so you can see the exponential factor here of the strength of those earthquakes right there. So you can see that earthquakes can be quite devastating, can release a lot of energy, and you can also create something like this for volcanic eruptions too. And I encourage you guys to look into your history books and looking at volcanic eruptions and the history of volcanic eruptions, as well as significant earthquakes that have happened around the world. So that's all for today's Weather Wednesday. We will keep you in touch with what's going on around the world. If you want to find out something for yourself, if you want to learn more, please send us your emails and send us your comments on Facebook, Twitter, and Instagram. We look forward to hearing from you guys. So until next Weather Wednesday, have a wonderful week.